my dear friends, welcome to my YouTube channel that is Learning and Programming with Chetan. Friends, in our previous video, we have discussed about need of concurrent collections in Java. And I hope that you have already watched this particular video, right? Now, in this particular video, we will going to discuss about the very important concept which you can see on your screen. That is the difference between concurrent hash map, hash map, hash table, and synchronized map. So guys, before starting this video, I hope that you all must be having an idea on map, right? So can you tell me what is map? So map is if we want to represent a group of individual objects as a key value pair, then we can use map, right? So what is map? Map is used to represent a group of individual objects as a key value pair, right? So I have key and I have value, and if I want to store the objects in this particular form, then we can use map, right? Now there are different types of map. Here on your screen you can see that we have hash map, we have hash tables, synchronized map, concurrent hash map, right? So what are their applications? Why we have these many numbers of maps where we can actually use them? So today we will try to understand the applications of these maps, what are the differences between them. So based on our requirement, we can understand that which particular map we can go with, right? So let us start our today's discussion with the help of this diagram first. Okay, so here by using this one, we will discuss about the differences between them, and then one by one we will explore it more. Okay, great. So guys, let me first tell you that what is the internal data structure these maps are using. So internally they are using what? They are using an array of buckets. Okay, so this is my array of buckets, and each bucket can have linked list. Okay, so this is our linked list. Okay, fine. Now let us try to understand about hash map first. So if we talk about hash map, then in hash map it is not thread safe. That is, we can use it in single threaded environment, which means that multiple threads can operate on it, but the result will be dangerous, right? Because we cannot judge the result if multiple threads will operate on hash map. Okay, so at the same time multiple threads can update the hash map object. That is why it is not thread safe. Okay, and it should be used in a single threaded environment. And our hash map can consist of one null key and multiple null values. Okay, I hope that till this point it is clear to you, right? Now let's move on and discuss about hash table. Okay, so if we talk about hash table, then it is thread safe. Okay, what is the meaning of thread safety? It means that it can be used in a multi-threaded environment. Okay, and how it is possible? Because all the methods which is present inside hash table is synchronized. Okay, so at a time only one thread is allowed to operate on our hash table object. So if my thread 1 is operating on this particular object of hash table, then it will log the complete object. Okay, and if any other thread is trying to operate on this particular hash table object, then what it will do? It is not allowed and it will wait. So first thread will complete the execution, then only second thread is allowed to operate on it. Okay, so it is taking a lock on a complete hash table object. Great. And it is having bit slow performance in comparison to hash map. Why it is slow? It is slow because at a time only one thread is allowed to operate on it and other threads are waiting on it, right? That's why it is bit slow in performance. Now, so let me tell you, when we discussed about hash map, when there one null key and multiple null values are allowed, right? But if we talk about hash table, then no null key and null values are allowed in hash table. Okay. Similarly, we have the same functionality of the synchronized map. So we have one utility class that is collections, right? From that collections, we can use a method that is synchronized map, and we can get the synchronized map of our map object, right? So similar to hash table, our synchronized map is also thread safe and it is slow in performance. Why it is slow? We know that at a time only one thread is allowed to operate on it. That is why it is bit slow in comparison to hash map. Okay. But here the difference is that here one null key and multiple null values are allowed. Whereas when we discussed about hash table, then no null key and no null value is allowed in hash table. Okay, great. Now let us discuss about our concurrent hash map. Okay, this is an important one. So here multiple threads are allowed to operate on concurrent hash map object. How it is possible? Because when we discussed about hash table and synchronized map, then there it was taking a lock on a complete object. Whereas in concurrent hash map, it is taking a lock at a bucket level or segment level. That is, we have discussed that our map is having an array of buckets, right? So this is my first bucket or segment, this is my second segment, this is my third segment, and this is my fourth segment. So when we are performing a read operation, then it's fine. Multiple threads can read different buckets at the same time. It is not taking any lock. And when we are performing any update operation, then in that case, what is actually happening? So that we will discuss by the help of another diagram. Okay. So let me quickly tell you that it is bit fast in comparison to hash table and synchronized map. Why? Because here multiple threads are allowed to perform read operation, okay, and also the update operation. Okay. So here my first thread is working in the first segment, second thread is operating in the second segment, it is updating it, okay, and multiple threads are performing the read operations. Now, if the third thread which is trying to operate on the first segment, then only it needs to wait. So here we are not taking the lock on a complete object, but we are taking lock at the segment level. Okay. And here it is thread safe. It is having fast performance, and similar to hash table, here also null key and null value is not allowed. Okay. Great. So guys, I hope that till this point it is clear to you, right? Now let me share one more diagram with you and let us try to understand that what we have discussed about our concurrent hash. Okay, so this we have already discussed that our concurrent hash map is having an array of buckets, right? Or array of segments, and each segment or bucket can have linked list. Okay, so if we talk about one node, then our node consists of key, right? It consists of key, it consists of value, and it also consists of next pointer, which is actually pointing the next node, right? It is having the address of the next node. Great. So here in this diagram, you can see that we are having an concurrent hash map, and it consists of different entries, right? So we have different entries here in different segments, and here you can see that in one segment we are having an list. Okay, that is we have multiple entries in a single segment. It is also possible in HashMap. I hope that you already have a better understanding on working of HashMap. If not, then you can watch tutorial on the channel. Okay, it is already available for you guys. So here in concurrent HashMap, we are taking lock at a segment level. Okay, we are not taking lock on a complete object, but we are taking lock at a segment level. So if we talk about read operation, then multiple threads can perform the read operation at a same time. Great. It can be used in a multi-threaded environment. And if we talk about the update operation, then suppose I am updating this particular key. Okay, I am updating the key which is having value as 35, and I want to update its value as 90. How I can do that? I can use the put method, okay, and I can update it. So it will take lock only on this segment 4 and other segments are still allowed. So another thread, maybe T2 thread can come and it can operate on segment second. Another T3 thread can come and it perform operation on segment 3. It is also possible in concurrent hashmap. So I hope that with this diagram it is clear to you guys, right, about the internal working of concurrent hashmap and how it is different from hashmap, hashtable and synchronized map. So you can easily judge that when you can use concurrent hashmap, right? Great. Now without wasting much of our time, let us discuss more about the differences between them, right? So here by the help of this another diagram, let us see the difference between hashmap and concurrent hashmap. So let us discuss about our first point, that is synchronization. So if we talk about hashmap, then it is not synchronized, that is it cannot be used in a multi-threaded environment and it is not thread safe, right? We have discussed 3 points, right? Great. If we talk about concurrent hashmap, then it is synchronized and it is thread safe and it can be used in multi-threaded environment. Okay. Now let us discuss about our next point, that is it is introduced in Java 1.2 version and concurrent hashmap was available for us from Java 1.5 version. Okay. It is present in java.util package and concurrent hashmap is present in concurrent package of java.utils. Okay, great. If we talk about null key and null value, then yes, one null key is allowed in hashmap, whereas no null key is allowed in concurrent hashmap. And in hashmap, multiple null values are allowed. Okay, whereas in concurrent hashmap, multiple null values are not allowed. Okay, great. Now let us discuss about the nature of iterators. So the iterator which we are using to perform various operations in hashmap is fail fast. That is when we are changing or updating the structure of hashmap, when we are modifying anything in hashmap while iterating, then it will throw concurrent modification exception. Okay, that is why it is fail fast. Whereas concurrent hashmap is fail safe, that is we can also change the structure or modify our concurrent hashmap object during iteration also, and it will not throw any concurrent modification exception. That is why it is fail safe. Okay. Now let us discuss about our next point. Then yes, whatever you're seeing on screen is right. Hashmap is bit fast in comparison to concurrent hashmap when it is used in a single threaded environment. Okay. Last but not the least, if we talk about that where we can use hashmap, then we can use hashmap in single threaded environment. Okay, whereas we can use concurrent hashmap in multi-threaded environments. Okay, we have already discussed that how and why we can use concurrent hashmap in multi-threaded environment, right? I hope that it is clear to you whatever we have discussed till now. Now guys, this is our last concept of this particular tutorial and we will try to understand the difference between concurrent hash map and hash table. Okay, great. So let us try to understand the difference between concurrent hash map, synchronized map and hash table. So if we talk about hash table, then yes, it is thread safe. Okay, and synchronized map is also thread safe and concurrent hash map is also thread safe. Fine. But hash table and synchronized map is taking lock on a complete object. Okay. Whereas if we talk about concurrent hash map, then it is taking lock at the bucket level, right? And not at the complete object level. Fine. If we talk about hash table and synchronized map, then at a time one thread can operate on map object, right? Whereas if we talk about concurrent hash map, then multiple threads are allowed to operate on concurrent hash map object, which we already discussed, right? Great. Let us discuss about our third point. So here, so when we are performing the read operation or write operation, it is taking a log on a complete map object. Here also the same situation is there, and in case of concurrent hash map, read operation can be performed without any lock, okay, and write operation is taking lock at the bucket level, okay, fine. If we talk about hash table and synchronized map, then their iterator is fail fast. Their iterator is fail fast, okay. What do you mean by fail fast? So suppose I am inserting an item in my hash table object and at the same time I am iterating it. So I will get an concurrent modification exception. Okay. Whereas in case of concurrent hash map, it is fail safe and will not throw any concurrent modification exception when we are performing an iteration and we are trying to modify our map object. Okay. Great. Let's discuss about our next point, which is an important one. So here the null key and null value is not allowed in concurrent hash map, same as the case with the hash table. But in synchronized map, one null key is allowed and multiple null values are allowed. Okay. And the last one is that it is introduced in Java 1.5 version, and hash table was a legacy class which was introduced in Java 1.0 version, and our synchronized map was introduced in 1.2 version. So I hope that whatever we have discussed in this tutorial is clear to you guys. Still, if you're having any doubts, then without hesitating, you can ask me your doubts and your queries in comment section.